We're all surrounded by this invisible giant. It's a technology that powers pretty much every piece of modern life, from our cars to the cloud. And yet, most people have never even heard its name. So today, we're going to pull back the curtain on one of the most important, most influential inventions in the history of computing.
So let me ask you a question. What's the one thing that runs your smartphone, the super complex systems inside your car, and, well, the entire backbone of the internet you're using to watch this right now? You might think it's some shiny new tech, right? But the answer is something else entirely.
Yeah, it's not a flashy new app, it's not some recent breakthrough, it's a quiet, incredibly powerful 50-year-old programming language called C. And its story, you'll see, is pretty much the story of modern computing itself.
To really get your head around just how massive C's impact is, you kind of have to know where to look. But once you start looking, you realize it's not just somewhere, it's everywhere.
Okay, let's start with the device you're on right this second. Doesn't matter if it's Windows, Mac OS, or Linux, the very heart of it, the kernel, which is basically the translator between your clicks and the computer's hardware, that's written in C. It is the literal digital bedrock that everything else is built on.
And C's influence goes way beyond our computers and out into the real world. You know those tiny little microcontrollers in a smart thermostat, the brains of your car's engine? Or how about the flight software for the Mars Curiosity rover? Yep, they almost all run on C, because it's just so efficient and it can talk directly to the hardware.
But here's where it gets even deeper. The actual tools that programmers use to build other software, like, say, the interpreter for a language like Python, that's written in C. The huge databases that store all the world's information, the routers that direct all the internet traffic, all of it is powered by C. It's like the infrastructure of our digital infrastructure. So the big question is, how did this one language get so dominant? Well, to understand that, we have to jump in our time machine and go back to the early 1970s to this legendary place called Bell Labs, where a couple of programmers were facing a really big problem. So before C existed, operating systems were all written in something called assembly language. Now, this stuff was super fast, but it was tied to one specific type of computer. That meant software was totally locked to one machine. So, building on an earlier language called B, a programmer named Dennis Ritchie created C. And then, in 1973, he and Ken Thompson did something that was absolutely revolutionary. They rewrote their entire operating system, Unix, in this new language. And this was a total game changer. For the very first time, an entire operating system could be moved or ported from one kind of computer to another with hardly any effort. C basically found the holy grail. It was a portable assembly language. It gave programmers that raw, close-to-the-metal power they needed, but with the flexibility to run their code almost anywhere. Seriously, this changed everything. But all that power was built on a really distinct philosophy, one that's a bit of a double-edged sword. See, C offers programmers an incredible amount of freedom, but with that freedom comes an incredible amount of responsibility. It's all about trade-offs, right? On one side of the scale, you get absolutely blazing performance, portability, and direct control over the hardware. But on the other side, C has no safety nets. The very real risk of memory errors, a really steep learning curve, and zero built-in protections, that's the price you pay for all that power. And this all comes down to one simple, really powerful motto: trust the programmer. You know, where most modern languages act like a cautious co-pilot, always double-checking you and protecting you from making certain mistakes, C just hands you the keys to the plane and expects you to know how to fly. C just flat out assumes you're an expert. It gives you the keys to the entire machine, letting you manage memory addresses and hardware directly. That's what makes it so amazing for writing things like operating systems. But if you make a mistake, like say you access the wrong piece of memory, C won't stop you. And the results can be anything from a simple program crash to a massive security vulnerability. So because C was so revolutionary, and because it was tied to the hugely influential Unix operating system, it didn't just build the world we have today. Nope, it became the ancestor, the blueprint for pretty much all the languages that would come after it. Just think about the most popular programming languages out there right now: C++, Java, C#, JavaScript. They all inherited their syntax, their core ideas, directly from C. Even brand new languages like Rust and Go are basically having a conversation with C's legacy. They're trying to keep its power while adding all the safety that it lacks. C is truly the grandparent of modern programming. Okay, so you might be thinking, with all these newer, safer languages around, why would anyone still learn C today?
Well, the reason is actually pretty profound. It's about understanding the fundamental laws of how software actually works.
There's this great saying that just captures it perfectly. Learning C is like learning the physics of programming. It's not just about learning another language. It's about understanding the machine at its absolute deepest level.
See, when you learn C, you're forced to deal with all the things other languages hide from you. You learn how a computer's memory is actually organized. You use concepts like the stack and the heap. That kind of discipline just creates more efficient programmers, and it gives you foundational skills for critical fields like cybersecurity. And honestly, it makes you a way better problem solver in any language.
So at the end of the day, C isn't just some old language. It is the essential bridge between the abstract ideas that we have in our heads and the actual electrical signals firing inside a processor.
C laid the foundation for our digital world 50 years ago. And believe it or not, that foundation is still holding strong. It really makes you wonder, with a base this powerful and this enduring, what incredible new things will the next generation of programmers build on top of it?